Hello, everybody. 'Tis I, your fearful host of the Into the Impossible podcast, broadcasting live on Friday, January 6th, 2023. Still writing 2022 on my checks and my paychecks. You have to sign the front and the back of your paychecks, don't forget. And I thought it would be a lot of fun to answer some questions and also to celebrate the fact that we have 80,000 subscribers on this channel now on YouTube alone, another 50,000 on audio. And I really want to thank you all for such incredible support, and love, and generosity with your thumbs and your comments and all the cool stuff that you guys are doing. And I thought it'd be fun to take some maybe some live comments and questions and just have a good time before the sun goes down and I turn into a pumpkin in just a few more minutes. About an hour. We'll try to do this for an hour. And it's really gratifying to see the growth of the community and all the feedback tripling and doubling faster than a virus in its R factor. And it's hopefully a positive mind virus transmitting to you all and sharing with you all. And I learned a tremendous amount from my listeners and guests, obviously. I just recorded 2 episodes in the last 2 days, one with a brilliant young postdoc in the UK and the US, Oliver Philcox, who is part of a team that's claimed detection of very, very interesting phenomenon called cosmic cosmic parity violation, which, in the words of Mark Kaminkowski, one of the most eminent scientists alive and a friend and a mentor, could lead to a Nobel Prize for Dr. Philcox, and you'll see that soon. And I already have a Nobel Prize that I'm waiting to give him that I stole from my friend Barry Barish, who I'm doing a in-person interview with in about 2 weeks at his new home institution of the University of California. So we're colleagues. He is at UC Riverside. And I'm going up there to give a colloquium, and he will be there, and he and I will do an episode about his life story and kind of follow up on the 3 or 4 conversations we've had. I've interviewed him, and he interviewed me once on the podcast as well, and that was a lot of fun. Of course, he wrote the foreword to my latest book called Think Like a Nobel Prize Winner, and you can read all about that in that book. And also want to encourage folks to subscribe to my mailing list. It's there, briankeating.com/list. If you're in the US, you have a chance to win real space schmutz. So meteorites. I keep them somewhere around here in my laboratory setting. Let's see. I'm at a loss for them right now. Oh, here's one. Here's one. So if you want some, you got some. If you're in the US. And it's just been tremendous. Wow. T. Carr, my brother from another mother, the man, the myth, the legend. Thank you for $100 super chat. That is just insane and so generous of you. Folks joining us from London, from Laos, from all around the world. Oh my God. It's so cool. I never thought about this would be a possibility, obviously, when I was a kid, but even a couple of years ago. I mean, this channel is only 2 years old. And we've had incredible growth, and really the growth allows me to do a tremendous amount more and gives me the energy to really up my game. And I built out a studio, or in the process of building a studio, here in the laboratory at Keating Labs at UC San Diego. And we got all sorts of cool stuff coming for you this year. But, when somebody wishes you a Happy New Year and it's, February 3rd, you kind of think that they're an idiot. And I wanted to make sure that I released my favorite kind of content, top hits from astronomy and physics as soon as possible into the new year. And ideally that would have been on December 31st before the new year, but I got laid up with some kind of illness. I don't think it was COVID. But I'm feeling better and things are going well. And I did end up doing a Twitter space in which a friend of the show, Eric Weinstein, joined. And that was great. So you can find that. I made a video from it, and it's on the channel. And just one more reminder, just to please check out the video that released today, which, not surprisingly, confirmed the work of an up-and-coming physicist. I think I have him around here somewhere in bobblehead form. This is Galileo. I got Galileo here. And that's Albert Einstein, whose gravity remains ununified with the notions of quantum mechanics. And some of that's due to the work of the famous ice cube experiment, which is located at the South Pole, where I've spent many a day freezing my tuchus off, as they say. And I love it down there. And Franz Halsen leads the ice cube experiment. I had an interview with him, which is really one of my favorites of 2022. And he's just such a generous, honest, vulnerable, deep individual. Knew Georges Lemaitre, and we talked about that. Talked about pedagogy, how to be a mentor, how to be a teacher, how to be a scientific leader. We almost, ran out of time recording space. He has so much wisdom to share. So today's video is about Ice Cube's actual discovery, which led to me inviting him on the podcast. And I actually had him as a professor a long, long time ago. Michael, Dan, how are you? Shabbat shalom. And I wanted to kind of, riff off that with a deep dive into the experimental details of Ice Cube and what allowed them to make this announcement back in October in Nature magazine about a confirmation that Einstein was right, that the laws of what are called Lorentz invariants are respected throughout the universe. So that was a really fun discussion I had with him, but the video is about the actual ins and outs of the detector and how it works and how they actually did constrain Lorentz invariance violation, and what we can do about that going forward so that we can really learn if gravity and quantum mechanics are actually unified or if they're not. There's no law that says they have to be unified. And a lot of people kind of act in physics as if it does have to be unified, but there's really no mandate, as I say, letter from God that says we have to do that. And when I discuss this phenomena, that it's very difficult as a guest that I haven't gotten yet. He did promise to come on. Nima Arkani Hamed has promised me to come on. I was supposed to be with him this week in Glasgow, in Edinburgh. Not Edinburgh, as I said by accident when I talked to the great Neil Turok. Neil invited me to a conference that's going on this week up there in Edinburgh. And I couldn't make it because I'm going on a super secret mission in the next week and a half, and it would have required me to go and just do some crazy stuff that I was unwilling to do given family demands. But anyway, we'll stay tuned for more information about that. Today is all about the top hits of 2022 and what you guys think about it, and whether or not you agree with some of the selections that I chose and what we can look forward to in 2023. And I did post a poll on my YouTube channel, Dr. Brian Keating, where you're watching right now, and it got over 1,400, 1,500 votes, and I was kind of reluctant to put down what I knew would be the greatest hit of all of 2022 in the world of astronomy, which was JWST. So I put down I put down 4 real options. Nuclear fusion yielding net positive energy output, which we talked about with Professor Charles Seif in late December. The wormhole that was allegedly created in a quantum computer. The fact that the phosphine claims, which is a biomarker that Venus was said to have had. About 3 years ago, I had an episode with Sarah Seeger and other collaborators from MIT and her group and other groups that claimed they had detected this molecule, which looks a lot like ammonia, except instead of having nitrogen, it has phosphorus, so it's pH3 for you playing at home instead of NH3. And that was said to be not only really consistent with a biological origin, but really consistent with that life form existing in the clouds of Venus, where we're used to thinking about only carbon dioxide and future hellscape that may await us on Earth if we don't take heed to Tim Palmer, who's past guest on the show, and his advice to create a CERN-like organization for combating climate change. So look at that episode. So there was that option that got the least votes. 6% of you thought that was a big news, that we ruled out a discovery that had been claimed several years ago to much fanfare. And actually, that reminds me to plug a future video that I'm going to do another solo episode when I hit 90,000, maybe. I don't know. We'll see when I do it. But that's what I call the academic media hype complex. Kind of like the military industrial complex that Eisenhower warned us against. But in this case, it's the super cycle that occurs when scientists and the media kind of form a flywheel, which then creates this unstoppable juggernaut, leading through to perhaps unretractable claims. And it makes it extremely difficult, high pressure on scientists, raises tons of ethical issues that we are wholly unqualified to address in most cases. Let me speak for myself. And I want to use some of my kind of personal experience with these phenomena, including my bicep experience that I wrote about in my book, Losing the Nobel Prize. And I also want to include some other things that have come out, namely the nuclear fusion issue, the wormhole claim, and the phosphine retraction, and what these do to not only to the public's perception of science, but also to scientists themselves in kind of the sociology of science. But today we won't talk about, so look for that video, the academic media hype complex. And that'll be a fun video to do. And I hope to present it in the not too distant future. But if you want to help the channel, please, do things like you guys are doing. Leave thumbs up, leave comments, but most of all, really encourage your friends and family. People ask how to help me. I love money. No, I don't love money. Money's great. It's great to get money, big super chats and there. But really, I'm trying to expand a mission, and the money will help me do that because I have to pay producers and technicians and so forth to edit this, and it's really so gratifying that you guys tune in. People watch thousands. I look at these huge channels that have way more way more subscribers by a factor of 10. And you guys are more loyal and you're watching these videos longer. And I'm always, as I said, I'm trying to up my game. And so if you like what I'm doing, you can do a couple things. First thing is really encourage people to subscribe to the channel, but also subscribe to the newsletter. I send out juicy little tidbits of what I'm thinking about. And that's something that YouTube can't really squelch. I've had a bunch of videos lately, including the climate police putting a stamp of disapproval in some ways on my video with Charles Seif. So we talked about nuclear fusion and how the nuclear fusion, may be hype as well. And that video, which is about solving climate, catastrophes, all right, if we have a kind of unlimited energy source, we could scrub the atmosphere of every single carbon dioxide atom that we have. We're just limited by energy. So that was a positive thing, that the human ingenuity can present a solution to climate change. And yet the gods of YouTube sort of suppress it. They put a warning label on it, linked to UN. I don't know why to the UN. I was hoping they'd link it to Charles Schwab or the World Economic Forum, but they didn't. But nevertheless, we keep going. I had a very wonderful conversation, as you know, with Jay Bhattacharya, one of his most revealing and deep interviews with, the only faculty member that's really runs a podcast like this and that has reached out to him. That was slapped with a COVID-19 Wikipedia, warning and, be careful and demonetized and so. So again, money is wonderful. I can't thank you guys enough for that. That is such a complete blessing. But it'll be great to really grow the audience. As I say, a lot of things will happen if we get bigger. We can certainly get even more kind of phenomenal deep dives and guests. And I know I'm not afraid to take on controversial topics. And some of those will require your patience and your support. There's a very, very good possibility that Jordan Peterson is going to not only come on the podcast, but maybe do it live in person, either here in San Diego at some point or in Toronto. And I know some of you guys don't like him. I know it. It's definitely true. And I don't agree with everything he says as well. But the fact is, he's a brilliant individual. He's a cultural phenomenon. He has great insights into other dimensions of my personality, including being a father, including being a man and being a scientist and trying to understand essence of nature and so forth, but also being interested in topics like religion and things. I'm not interested in the culture war. I'm not going to talk to him about trans pronouns and COVID-19. No, I don't care about that. But I do want to talk to brilliant individuals, and that will be, a very, very cherished opportunity if I get it. And it looks likely I will need your help because a lot of people subscribe. I talked to my friend Kurt J. Mungle yesterday, um, and he's been a great friend. And I was on his 8-hour marathon on New Year's Eve last week, and we chat all the time. And he may be lurking here and there. And, he kind of advised me, be careful not to lose subscribers because it's much harder to, keep a subscriber and, get them back than it is to gain a subscriber. And Alien Girl, I agree. Kurt rules. He's kind of been an inspiration to me. But I took slight disagreement. I said, look, if you just do what your audience wants, then you might not really be in this for the right reason. And I'm not accusing him of that. I'm just saying you might be captured by their intentions. And that may not take the channel where you need to go. I mean, look, if I want to monetize this channel and really just amp it up and get, quit my professor job and do all this stuff, I mean, we could do it. Kurt does do YouTube 100% full time, and he's excellent at it. And I respect him tremendously because he's doing the real thing. I am blessed that I don't have to do only YouTube. I have my books, I have my podcast, I have my university professorship, and I get to interact with the most brilliant people on earth. Such that if YouTube decides tomorrow to cancel my channel, life will go on. I'll have other opportunities. Most of all, being a scientist working on cutting edge research at the literal top of the planet in Chile at 17,200 feet, the Simons Observatory, which is my lifelong dream. So, on the other hand, I don't want to be captured, but I also want to have good conversations and I want to grow the channel. So, anyway, if you can help out, and by the way, Kurt was on Jordan Peterson's channel, so it's even more than maybe I'm doing. So if Jordan's good enough for Kurt, he's certainly good enough for me. Anyway, let's move on to the stories, shall we? And so I'm not going to talk too much about the items that I mentioned, except number 4 on my list that got 33% vote was the fact that NASA has commissioned a panel for studying unidentified aerial phenomena. And that is, I think, a very, very important story because it really represents the first time that we were able to get buy-in, at the federal level from, the highest or most respected agency, which is NASA. I mean, that's just a fact that studies space. I mean, Space Force is coming on strong, but it's still kind of in a nascent phase, and it has a different mandate than NASA. So a lot of what we'll talk about today have to do with NASA's discoveries, starting with the very first thing that happened, in the early parts of 2022, which was the arrival of this object in real form. So one of the cool things about being a professor at the greatest university in the world is that I have the greatest students in the world, and they make me all sorts of presents. So this is available. I should give this to T. Carr at some point. If he comes and visits, maybe I'll give this to him. And in gratitude, this is real gold. That's solid gold plated hexagonal mirror. So in the real JWST is 6 meters across. This was 3D printed by 2 of my students and lovingly assembled. It's real mylar down there. How cool is this? I mean, I got these awesome students, and they're going to go out into the world and be even better scientists than I am if all goes as planned. So JWST gotta be tops of stories, at least in astronomy. And some of the discoveries that it made were just absolutely breathtaking from a visual perspective. But we astronomers, since the time of this guy, Galileo, have been looking up at the heavens with telescopes and making hypotheses, modeling what is going on in the heavens above. And by doing so, we are able to really instantiate for the first time the scientific method. How can we form a hypothesis, use observations, refine the hypotheses, discard inconsistent phenomena, and come to a closer approximation to truth? And that reminds me, there's a great YouTube channel called Closer to Truth. I'm going to be on that channel, which is coming out. It'll be also on television. I did some amazing video footage with my good friends who run that channel, Robert Kuhn. They've got 500,000, 1 million or more people, and look for a collab with them coming soon, along with my friend Arvin Ash, who's agreed to do a collab with me about the physics of time. That's coming soon. So I think you're in for a really phenomenal 2023. But in 2022, this object, JWST, made it to L2, this very special point called Lagrange point number 2, that orbits in a not stationary position, but it does orbit in a stable orbit 1 million miles from Earth, so 4 times the distance to the moon, and took these phenomenal images. I suppose if I was a better YouTuber, I could fold in some of the pictures. I'll try to put up some here as we're speaking here. So just beautiful images here. The Carina Nebula. Let's see if I can get that going on the screen. Here we go. Bam. Covers up me. And that's okay. Beautiful. And then we had, of course, the pillars of creation. Let's do that one. Here we go. This one gets a special place in the stream. Wabam. Let's see if that comes up. Look at that. That's amazing. That's beautiful. Now, as beautiful as these are, that's incredibly important. And of course, things like the Hubble Deep Field were incredibly important last year and in years past. But what do we get scientifically that we didn't know before? We got a lot this year from JWST, including the initiation of a great controversy. No, I'm not talking about the fact that James Webb himself was really exonerated from charges of homophobia that came out from past guest Hakeem El-Shai. You can find that episode. And I reposted it also in audio form. And there was a New York Times article on the front page of the New York Times really clearing not only James Webb's name, but Hakeem's as well, because he had come under kind of a very serious and vicious and unjustified attack, in my opinion, that sought to destroy his reputation. And a lot of that has been undone, thankfully, and it was great to see that in the New York Times and sort of the paper of record to get the attention that Hakeem deserves and to really clear the name. And also Barbara Webb, who may be out there, James Webb's daughter, watching. She's subscribes to my Twitter feed, as you guys all should, Dr. Brian Keating, as well as the YouTube channel. So it was really great to kind of do a kind of rehabilitation. Not that he needed my help, James Webb. I mean, his phenomenal contributions to humanity through not the least of which the Apollo program, in the very extremely early portion of the Hubble Space Telescope with Spitzer. It wasn't really called that back then. Lyman Spitzer at Princeton. But these are some of the great triumphs of 2022. And I'm told that interview that I did with Hakeem's presentation, played a not insignificant role in the publication of the story that did emerge in the New York Times. And so that's gratifying that I could play a role and so forth. We also had news about exoplanets from JWST. Here's an image here. That's way too small. I'll blow it up. Where we actually look at data and we see the presence of complex molecules, carbon dioxide, and other things in the atmosphere of an exoplanet. Not just seeing that they exist, which led to the Nobel Prize in 2019, but the fact that they have complex chemistry in their atmosphere. Some say if you see things like carbon dioxide, that's a harbinger of life. So it's not necessarily proof that life exists. It may not even be evidence of the possibility of life. In other words, it might not only be it might not only be not sufficient. There's so many knots here. Knot theory is my hobby, but it also may not even be necessary for life, as we knew from the phosphine claim that phosphine is a biomarker that has nothing to do with carbon dioxide. So that being ruled out, does that enhance or constrict the possibilities of life? I don't know. It's certainly, we didn't spot, space Disneyland on WASP 39 Bravo, but it's an important proving, stepping stone, perhaps, towards confirming the existence of life on other planets, or maybe ruling it out. And it's fascinating to think about what Webb will do in the next year. Of course, there was controversy regarding the existence of the Big Bang itself, claimed by an individual by the name of Eric Lerner, who may be out there as well. And I did 2 videos about the existence or not of evidence for or against the Webb telescope's images of galactic structures, and whether or not those galactic structures provide any evidence for or against the Big Bang's existence. And I did one solo, and I also did one along with my friend and colleague, Garrett Lewis, professor in Australia. And that was really quite delightful to go into a deep dive and avoid so-called, paradoxes where we enter into potentially ad hominem attacks that Lerner had accused us of. But in reality, I think it's important to note that there are flaws. There are problems with the Big Bang. There are problems with what's called lambda CDM, the kind of concordance model that we call it, that the universe is dominated by matter of an unknown character called dark matter. We had plenty of videos about that this year. And also its energetic energy budget is dominated by something called dark energy, which we know even less about, and we can't even access and get good limits on experimentally in the laboratory, the way that we're doing stuff even here at UC San Diego with my colleague Kai-Xuan Ni, past guest, and Elena April of the Xenon 1-ton experiment, phenomenal, world-beating limits on the amount of particulate dark matter. So we entered into some discussions of MOND, alternatives to dark matter in particle form. What if we can modify the laws of relativity, but even before we modify relativity, we can modify Newtonian dynamics? What would that say for the not only presence or absence of the type of dark matter that most scientists do believe exists, but more than that, we would have some inkling as to where the universe could be headed in terms of its future evolution on galactic and subgalactic scales. So we did some deep dives there and talked about galaxies that don't have dark matter. We talked about galaxies that are only made of dark matter, or at least seem to be dominated by dark matter. And I think it's really fascinating to know that that's the way good science works. It's not as, my friend Eric Lerner, no, I shouldn't say my friend, that's usually connotes a put down. Let me say Mr. Lerner, it's not a sign of unhealthy, biased, censorious scientific process because you can't get your paper published. In fact, it might be seen by somebody who is truly pursuing knowledge that it may be that it's much harder. I've had very few papers accepted in my life on the first try. I published 200 and something papers. They've been cited 13,000 times maybe. And not one of the 200 papers, well, one of them was. One of them was just accepted as is, and that was extremely gratifying. Paper I wrote 10 years ago last month about calibrating cosmic microwave background polarization experiments like the kind that we work on with the Simons Observatory. So these are things that we want to have in place that will perhaps point us to new physics. And the fact that some will claim that the inability for observations, say by Webb, to be incorporated with the current prevailing paradigm, that's not a crisis. You don't just say, oh, all of physics is moot. I guess I picked the wrong profession. I should become a YouTube streamer full time. And obviously I don't have the talent for that. But the point being, we can't look at the gaps or the flaws in current observational connections to our prevailing hypothesis and throw it all out. A good scientist, there's an article by James Peebles, renowned scientist, the grandfather of modern cosmology, involved in everything from the discovery of the cosmic microwave background in 1965 He missed out and was scooped famously to our first understanding of how dark matter really is inescapable given the distribution of what are called CMB anisotropies in the 1980s. I had a nice conversation with Professor Dan Green about that today in person in a studio about 10 feet over that way. And look for that. Dan's, another thing I want to do this year is not have like, oh, I have to get on every Nobel Prize winner in the world, but just the most brilliant people, some of which happen to live here in San Diego. And I happen to, have the same person signing the fronts of each of our paychecks. These are phenomenal professors that I'm blessed to have. And that's actually how the podcast got started. If you don't know, I am affiliated with what's called the Arthur C. Clarke Center for Human Imagination, which has been around for about 11 years. And in 2020, when the pandemic hit, I realized that all these brilliant speakers like Freeman Dyson and others would not be able to come through San Diego anymore. And so I want to start to do remote interviews with them and record those remote interviews. Before that, I had Freeman on the podcast. In fact, he was my first guest on the podcast in 2017. It was audio only. And I realized, well, we're not going to be able to get him back. And sadly, he passed away shortly after the pandemic kicked off. But nevertheless, we had all these brilliant people coming through for the Arthur C. Clarke Center. And I was kind of in this position that I wanted to give back not only to the 190 people that would come to a lecture by these great intellects and that I'd get to moderate, but to everybody out there in the world. And we've been able to do that through this YouTube channel. So I'm very grateful for that. So let's get back to some of the greatest hits of the past year. So certainly the astronomy was really dominated by Webb. The fact that it not only worked almost flawlessly, it was hit by a meteor, but besides that, it kept spinning and was able to take images of everything from these distant galaxies, the pillar of creation, to things in our own solar system, like this object here, Neptune. Oh, no, that's Jupiter. But then next to it is a moon of Jupiter, and it's pretty phenomenal. They also saw incredible images from Neptune and its moon, Titan, just phenomenal, and imaging it is really just spectacular. We also had a return to the moon, which is kind of interesting. We haven't been to the moon in 50 years. And I like to point out it's longer that we haven't gone to the moon than the time period between the discovery and the kind of first explorers to reach the South Pole in 1911, 1912. It took 45 years for people to get back to the South Pole. It's taken longer to get back to the moon, and the moon has just as many possibilities, not only for scientific exploration, as I use it for BICEP. IceCube uses it for IceCube. You can see over my shoulder on this side, there's a picture of BICEP at the South Pole. This one is of the Polar Bear Telescope in Chile, where I just was last month. So it's really phenomenal. I hope we will get back there. I'm looking forward to Jessica Meir, who is past guest, two-time guest on the podcast. I interviewed her once while she was on the space station. Talk about that. See if Neil Tyson can do that. I mean, come on, Neil. Got to up your game, my friend. Had her on, and while she was on the space station, and then I had her on again, and she may be the first. She may be the next person on the moon, but if she is, she'd be the first woman to ever go to the moon. And I would just love that because she's an incredible human being. She spoke in our commencement this past year, and I just had a wonderful time hanging out with her. Some of you mentioned this experiment here. Leave a comment if you know what that is. This is a picture of an asteroid, which we slammed into unceremoniously. I wrote about that in my most recent Monday Magic email message list, where I share a meme. No, I don't share a meme. I share a memory, an appearance, something that's genius, something that is a beautiful image, and then a conversation, aka a podcast. So subscribe to the mailing list, and you'll get those about every 2 weeks. I don't like to spam. It takes a lot of time. I like to put a lot of effort into it. So DART slammed into this double asteroid redirection test, and it slammed into a moon of an asteroid. It's insane. Dimorphos, the moon of asteroid 85803 Didymos, in a test of planetary defense. That's incredibly cool because, if you watch Deep Impact with Bruce Willis, they freaking nuke that thing, and that's not the best idea. Or Don't Look Up, the great kind of cautionary tale movie that came out last year, which I liked. It's depressing, but it's kind of funny as well. We also had on Shep Dodelson, Dolman rather, and he explained this image here. What is this image of, everybody out there? It is the monster black hole at the center of our galaxy. Here, it's over my monstrous mouth. And that's our galaxy's black holes. It's a follow-up to their smash hit from 2 or 3 years ago, where they imaged M87, perhaps the most energetic of all objects. This one's really phenomenal because we can start to do multi-messenger astronomy, where we can compare the image made by this vast planetary-sized Event Horizon Telescope, which is a worldwide array of millimeter and microwave and radio wave astronomical telescopes from Chile to the South Pole and Europe and Africa. And we can take these images and compare with the results of my colleague up north at UCLA, Dr. Andrea Ghez, and past guest Reinhard Genzel. I'm trying to get Andrea on all the time. So far, no good, but we'll hope to have her on. So now we can compare optical and infrared imaging, direct imaging, with the event horizon, which you can't see, using optical or infrared imaging that Andrea and Reinhard do in their groups. You combine that, and you can start to test deep aspects of general relativity and extreme gravity. We could never do that before. And you can't do that with M87. So this was more important. It was actually a bigger challenge because our Milky Way's black hole is thousands of times less massive than M87. But it's, kind of the most important thing, as any real estate agent will tell you, is location, location, location. So we want to make sure that we have an actual understanding of this enormous monster behemoth in our own celestial neighborhood. That was another incredible discovery. We had several other kind of runners-up. As I said, the phosphine discovery was ruled out by this instrument here, which, I'm a pilot. I like to fly little Cessnas around. My dream was to fly on this as an astronomer pilot and captain the 747 known as Sophia. Unfortunately, it's shut down. It's probably out in the boneyard. It has I think an 80-inch telescope on it. And I'll never get to do it. So I snoozed and I loosed. So I won't be able to participate in this incredible stratospheric observatory for infrared astronomy. But they did manage to make this disconfirmation of this previously incredibly hyped up, including by people like me, discovery of phosphine allegedly on the planet Venus's atmosphere. So a swan song final flight for the Sophia instrument. We had a couple other pieces of news that were kind of null results. The dark matter, has yet to be discovered by the liquid noble gas experiments. We also had got inkling that we're not going to rebuild the Arecibo telescope, sadly. And we've had shows about many of these things here. So let's turn to physics now. So that was just pure astronomy. There are a couple of great physics announcements. So there was, of course, the announcement of nuclear fusion being achieved on Earth in a controlled fashion. We had achieved many hundreds of times have we had nuclear fusion take place on Earth. Unfortunately, those are in atomic blasts, and those require nuclear fission devices to initiate, to trigger. But this one had a trigger using 192 high-powered lasers that blasted into a deuterium-tritium diamond-sized pellet, igniting it and causing it to give off 2 megajoules of energy, I think it was, with only less than 1 megajoule of energy input in the sense of the blast that triggers it from these lasers. And this takes place over a trillionth of a second or so. Unfortunately, it's completely and utterly impossible to use this technology to actually, or to use this fundamental physics breakthrough to actually accomplish a working electronic power generation system. But nevertheless, it was an incredible breakthrough in many ways, and I think they kind of um, hope springs eternal, and I think this will take a lot of our attention towards maybe commercializing this. And just as commercial uh, pressures have been great for NASA in terms of really getting us to the moon again, really probably wouldn't have happened without Elon Musk and SpaceX kind of really pushing them to up their game in the private space sector. And I'm hoping this will happen, kind of in reverse, where government will then, provide impetus for private companies to then make leaps and bounds in their um, fusion game. So other things that took place that really fascinated me this past year had to do with fundamental particle physics, including the announcement of the so-called discovery of a pentaquark. So pentaquark is not five quarks necessarily. It's sort of a description that this type of particle could include a particle with five quarks instead of the typical three or two, and even what they called a tetraquark, which was a combination of two quark atoms, and then synthesized into, or in like pions, which are quark antiquark pairs. And this combined was really, it was sort of expected that you could have behavior of hadrons in this format. And it became kind of interesting to me. If you look at it, it kind of looks like a chemical bond. Like it looks like they're forming, within this five quark system, which is made up of the letters here: S, that's strange; C is charm; up is up quark; and then down, D is down. That it's almost like a molecule. Um, and then, but there's no electrons here, so it's very different. It's sort of molecular uh, appearing, but these aren't actually molecules. These are uh, hadrons, and combining together with things like pions in this very interesting and unexpected way. I thought that was a really cool discovery that colleagues at LHC had made. And we also had, of course, the announcement every October is Christmas for nerds. And we had the announcement of the Nobel Prize in Physics. And that went to people that were entirely expected to win for a long time, including the man on the right, shown here, Anton Zeilinger, who is a second cousin. I don't know. He and I are related in some way. The guy with the glasses here, in that he worked very closely with my good friend and late colleague Andrew Friedman, passed away 2 years ago, sadly. And Andrew had worked on this confirmation of the local realistic description of quantum mechanics using photons as sort of triggers from distant quasars. And so, in other words, they were able to understand the properties of so-called spooky action at a distance, and that was maintained and kind of ratification of the more or less how the standard interpretation of quantum mechanics that Einstein did not like, and verifying that it actually did take place. And it takes place not only on Earth in short separations, but takes place over the vast volume of our entire solar universe. And so Andy had a great role in that, and was some of the work was tangentially cited by the Nobel Committee. I just wish Andy could have been alive to witness it. So those are some of the top 10 hits. There was discoveries from the LHC-B experiment, which had been announced to great fanfare last year or 2 years ago. A discovery of this called bottom or beauty quarks. They had observed these rare phenomena, and then there was basically a claim that no, we don't have new physics discovery, and that there is kind of less room in some sense for modifications to the standard model of quantum mechanics. And that was sort of upsetting in some ways to many people. again, part of the academic, hype cycle or whatever that we'll talk about when I release this video that I'm tentatively thinking of calling the academic media hype complex. So that was, kind of a disappointment. As I said, there have been, many, many discoveries, but oftentimes there are discoveries that don't pan out. And there may have been other phenomena like that where you've witnessed these huge announcements, but then the breakthroughs don't hold up. And that's a tribute and a testimony to the self-correcting nature of science. So I'll be talking about that when I release this video, academic media hype cycle. I'll even talk about my experiences with it tangentially in the phosphine announcement from 3 years ago now, and in the disconfirmation of that, but also in the Bicep 2 affair that led to the great revelation that we don't yet have information that proves or excludes inflationary cosmological primordial perturbation formation in the early universe. So it was an exciting year, a year to beat. Hopefully we'll have a great guest coming up. Again, my good friend Eric Weinstein has committed to coming down and doing an episode in person at some point. I'll look for that. And look forward to an in-person interviews galore, including one that I just recorded this morning with Professor Dan Green of UC San Diego. Follow him at NU_phases on Twitter. And he had an epic tweet storm in December, tweeting out the last 40 years of theoretical and experimental physics, discoveries that did not win Nobel Prizes, but perhaps will in the future. So look for that in-person live interview with Daniel in just a few weeks. Dr. Oliver Philcox, not a professor yet, but he surely will be. And his announcement of a very, very tantalizing hint of parity violation, normally associated with activities of particle accelerators on Earth, discovered by Madam Wu, C.S. Wu. I have a video about that, the Nobel Prize that wasn't, something like that. And but we've never really observed it in cosmological scenarios, which in Oliver's words, as you'll hear, could imply that gravity doesn't obey parity symmetry. So parity symmetry is that if you reflect something in a mirror, it really is independently behaving than if you observe it directly. So if you look at the solar system in a mirror and then you look at it upside down, you can actually not tell which direction you're looking at it. Or if you look at some simulation of cosmic structure or the actual cosmic structures themselves, and I tell you, oh, you looked at it in a mirror, you just didn't know it, there's no way you can tell. But when you have more than a more statistical power, as Oliver and his team do, you can actually reveal the presence of very, very subtle parity-violating effects, which would have a stunning implication. I agree with Mark Kamikowski that if this is confirmed, it will be Nobel-worthy. So look forward to those interviews, and we have more. Phil Plait, the bad astronomer, is coming on for his new book. I've got it in the other room over there. Dr. Susie Sheehy wrote a book, The Matter of Everything, is coming on in a couple weeks, and that's a phenomenal book. And we'll be doing, as I say, a lot more in-person, high-quality 4K videos, and it will be a year to beat, and hopefully we'll crack that magical, mysterious, mystifying 100,000 follower threshold, and then I'll retire. No, I'm not going to retire. I'm going to keep doing it, keep providing you free content, greatest and best intellects, some videos from yours truly as well. So do leave a comment, thumbs up. I hate asking you. People tell me to stop doing it, but the fact is, it's just the rules of the algorithm, especially when you have people that are causing you to get suppressed, which is happening the more controversial guests that I have, like Dr. Jay Bhattacharya, and even Dr. Charles Seif, or Mr. Charles Seif. He's not a doctor, but he's a professor at NYU. And that gets slapped and demonetized and so forth. So do me a favor and spread the channel. And sign up for the mailing list. Do it now. Oh, I should say, if you have a .edu email address and you live in the US, I will guarantee send you one of these meteorites, one of these bad boys. Bad girl. I don't know where that. Here it is. So this is a highly magnetized fragment of our solar system and its formation 4.3 billion years ago. I'll send you some information about observing those meteoroids and meteorites. And you can get that chance at briankeating.com/list. But like I say, if you have a .edu email list, those are my target audience: undergraduates, graduate students, postdocs, professors. We have thousands of people, 10,000 people, and I just love it. So please do sign up for that. Little dose, spread the channel, share the love. Thank you guys so much for a wonderful 2022. 80,000 subscribers, up from 3 years ago now. And it's just incredibly mind-blowing that you guys are along for this ride into the brain, into the cosmos, and beyond. With yours truly, Brian Keating, Chancellor's Distinguished Professor of Physics, Associate Director of the Arthur C. Clarke Center for Human Imagination, signing off, wishing you all a wonderful weekend, thanking you so much for joining me on this wonderful ride into the cosmos. Be well, everybody. Thank you all so much.